go. First of all, so my name is Brecht. I'm on the Department of Customer Love, as we call it. So I chat a lot with developers. I help them solve their problems. I teach them how to solve their problems. And I'm joined also later on by Will, who's going to do part of the talk as well. So on the agenda, we're going to have a look at what we call real-time analytics, or real-time, versus what we dub just-in-time analytics. So what we mean with just-in-time analytics is basically, rather than continuously delivering data and analytics, deliver it when you need it the most and right on time. We're going to come back to this later as well. We're going to have a look at 3 Looker use cases from 3 different perspectives. And after these use cases, we're going to have a look at the technical levers that Looker actually offers to implement in your data stack as well. So let's dive in and start with real-time analytics, which is certainly a buzzword these days. So why not have data fresh, available all of the time? Because it makes sense. Fresher data means quicker decisions, mean eventually better decisions. Database technology has evolved. There's a substantial amount of improvement done in the last few years with newer technologies. There's also streaming platforms on the market now that make it very easy to do so. However, in these both cases, we still have the traditional database restrictions. Let's say real-time data means a higher query volume, means a higher billing tier probably, or a bigger cluster, etc. And on the other side, there's the ETL part as well. Some data needs to be processed, needs to be enriched, thoroughly transformed, and wait for other ETLs that might be staggered. The key thing in both these things is obviously cost. While it is possible, it doesn't necessarily mean you have to do it. So essentially, yeah, it comes down to this. So don't always deliver data as soon as possible, but deliver it when it's most useful and right on time. So enter what we call just-in-time analytics. So we're just going to go over 3 examples of types of data, or data freshness or latency, however you want to call it. So let's start with high-level data. So a good example would be average order value per customer. Essentially, looking at this, refreshing the page wouldn't change the numbers. So it's data that needs a lot of context. It's usually aggregated over longer periods of time and doesn't really make sense if you look at it on a daily level unless that customer makes, I don't know, let's say 10 orders per day. The second one is low-level data. It's still not event data, but it's actionable data that is aggregated over shorter time frames. It needs a bit of context. Think of it of delayed orders per day, or order status on a daily level. And then third of all, we have event data. And essentially, you can think of it as in all context is contained in that event. A good example is customer feedback or a customer complaint. So the benefits of trying to segregate it like this, these are just a few examples, obviously. But the benefits is you can really target this so data gets delivered the moment you need it. So obviously, for more staggered pipeline or high-level data, your data can be enriched. You can transform it. You can add more metadata from other sources, such as Salesforce or other forces. But it also means your pipeline's more manageable on that end. There's a case to be made for your data being more directly actionable, because you don't have a continuous stream of events that bother your business users or your consumers, so you can actually take action as soon as you have the data. And that brings us to the last point, is you can avoid data fatigue. So with real-time analytics, you can see a lot of people just get really indifferent towards data, and at some point they say, like, I'm not going to check this data anymore. Which means they will not take action on that data while they actually should. So, to kind of illustrate this example, we're going to have a look at 3 examples from a Looker perspective. So the first one we're going to have a look at is the DCL, the Department of Customer Love. The second one is from Solution Engineering, and then the third one is from our Customer Success team. And I chat a lot with developers, as I said. I'm not sure how many of you have used Looker Chat in the past. Wow, okay. That's more than I thought it would be. I don't know how many actually have talked to me, if you remember. Well, nice to meet you in person. So we're going to have a look at 3 different use cases starting with one event is a incoming chat from a developer. So let's have a look at how customer support, basically DCL, uses this. So our use case is we need to be able to action immediately as soon as a chat is marked as high priority. There's many factors that we use for this, but essentially as soon as it has a high customer impact, we want to make sure that we can allocate resources immediately and make sure that no further impact is spread out, or however you look at it. So in a nutshell, this means like we are immediately notified. We can allocate resources immediately. We can work with engineering, and essentially we can fix bugs fast. An overview of like how this pipeline kind of looks like is there's very little transformation going on. There's a lot of streaming going on. And on the Looker side, we do a minimum of modeling to make sure that we get instant notifications. All in all, this takes about 5 minutes, a bit less probably. The second example we're going to have a look at is the one from the solution engineering team. And for them also, they work with new customers and make sure that they can become successful Looker users. So part of that, their customers also use Looker Chat. Sometimes they come with problems as in, how do I model this particular thing, which is a very substantial thing to handle over chat. So solution engineers get alerted on a periodical, on an hourly, 2-hourly basis, and get a roll-up of how many chats their customers have done, and a short summary of the chat itself as well. And it makes them able to identify knowledge gaps and address these in a further co-development or teaching session with the customer. So in general, with these notifications that we have and the quick identification of knowledge gaps, essentially what we want is more successful customers and lower churn in the end. So the pipeline here is a bit different. We're still very much low level here as well. But essentially, we make it into our MPP. We use a bit of modeling there as well, a bit of PDTs, and for the rest, we have instant alerts using Zapier into Slack. So the final example is from customer success. And customer success has the important job at keeping existing customers successful. And how we determine how successful a customer is, or maybe if they are at risk of being less successful, I suppose, we have set up a health score. And this is a score that takes in a variety of parameters: daily usage, query time, query usage, but also chat usage, for example. And we roll all of this up into some complicated high-level metric called a health score, but makes them possible to identify immediately based on one single metric. So the big thing here is that customer success that have quite a big portfolio of existing customers, they can review and action data ad hoc. They don't always need to be updated every hour of the day of the week, that kind of thing. But they can review it as necessary. So the big thing is it's asynchronous, and it's a 360 degrees view of the customer's health. So it's coming from multiple sources, and it's enriched with a lot of other collected metadata, and it's usually seen over a larger time frame as well. So a good illustration here is, it says daily, weekly refresh, because obviously the pipeline doesn't take a day or 2 or a week. But to get all the necessary data, it takes quite a bit of time. So we feed in other data into our warehouse as well, and we make heavy use of PDT and a cache layer. So having seen these 3 short examples, now we're going to have a look at the levers that Looker offers you to actually implement this in your data stack as well. And Will here will take you through this.
Awesome, thanks. Yeah, so I really like that example myself, because it takes this one data point and it shows you all these different use cases, and real time wouldn't make sense. So when people say, oh, I need my data now, like that's usually not true. But you do sort of start to segregate these into at least what I would describe as operational use cases, where generally the data needs are pretty simple, immediate, versus more complex analytics, right? So you got your real-time notifications for immediate response. You've got notifications within a few hours into Slack for the folks on my team. And then you've got sort of those daily aggregate customer health scores. and as you guys are sort of thinking about your use cases, I think we always want to start with the needs, right? And so these are sort of the questions I would ask about the use case in order to help you segment where on that spectrum it lives. What is the tolerable latency, right? So do I need this information within an hour, within a day, within a minute? Is it single source or is it multi-source? So those notifications for the support team require no context. It's just, hey, there's a high sev ticket, we need to respond immediately. When we moved to hourly notifications for solution engineers, we need a little bit more context because we need to join into our CRM data to find out who is the right SE on that account who should be receiving the chat. So we're adding a little bit of context, so that's a factor. Do I want it live? Do I want it every day so I can see this no matter what? Or do I just want to be notified when a condition happens and be ignored when it doesn't happen? And then do I need a lot of history, right? If I'm looking at that customer health score, I want to know if usage is going up or down, and that requires a long view of historical data, versus if I'm just looking at what happened in the last day, I can keep my queries really simple. And then so based on these needs and how we sort of segment out our use cases, we can choose sort of these four big categories of technology levels. Your database technology, your blend between physical and logical data modeling, the query speed which you can optimize, which we touched on a little bit in the previous talk, and then the delivery method. So starting with the technology, it's funny when I joined Looker, BigQuery was not on the market, Snowflake was not on the market, Redshift was pretty new. I think for lots of us in the room, we think of these things as standard in the industry, and the reality is that there's lots of Oracle out there, there's lots of Teradata out there, there's lots of MySQL, there's lots of Postgres, and we need to be able to work with these things. And I would say, you keep these. So for most of our customers, even if they do have some sort of MPP database that's optimized for analytics, they also at the same time will have Looker connected to an operational data store as well. Obviously not a pure transactional processing database, but a database that's going to be a read replica of that. Those are really good for real-time analytics. They're usually free or nearly free if they're already in place for processing. And of course, you can sort of model that data in Looker. You go back a couple years ago, and people started investing a lot more in these MPP databases. And so MPP databases, based on columnar technology, are not great at processing transactions, but they're really good at scanning large amounts of data. So for those broad-based historical analyses, and for data analyses that require lots of context from data sources merged together, that works really well. The trade-off that these introduced was the fact that because you're not loading data as rows, but because you're loading it in columns, these are more optimized for batch loads. So generally speaking, most databases, most ETL processes, you're generally going to be looking at minimum 15 to 30 minutes latency when you're bringing data in. And so again, it's really helpful to have both. If your organization does need to have something that's sort of best of both worlds, you can look at things like Kafka and real-time streaming into MPP databases. I know one of our customers, MyHeritage, has a really good blog post about some of the technical options they evaluated when they were doing those. It does come at a cost. So both in terms of financial cost as well as the engineering effort. Again, I think a lot of times people see streaming real-time data now and they want it. I would say for 90% of our customers, at least, they get by with a combination of real-time replicas from transactional databases and columnar databases for historical analysis. But streaming is certainly an option as well. So you've got your data in your database. How are you going to model that data? If there's any Ralph Kimball fans here, please don't get mad at me. I'm slightly abusing physical and logical data modeling, so don't riot. But I do think about sort of this trade-off that you have between a few different ways of modeling your data. Modeling it with your ETL processes, modeling it on the fly, and then PDTs, which I like to think of as a nice happy medium. ETL, we're not completely throwing out the handbook on sort of traditional data warehousing techniques. And I think of ETL, even when you have Looker, even when you have LookML, as really powerful for getting your data in a place where it'll work well. And so you're not generally putting your sort of agile analytics here, but keeping your data clean, deduping your data. Maybe you have 5 different tables of different event types. Put those in a single table that's a raw event stream so that you can look at all these event types in a single query. If you have a star schema, denormalize those tables on load. MPP databases are going to be better at big, wide, flat tables as opposed to lots of small tables and joining them. So there is still stuff to be done in ETL land in terms of keeping your data really flexible. But then I think when you get into the Looker data modeling side, and by the way, everything that you see underlined in purple is a Looker feature that's available to you guys. I think there's this important balance between PDTs and on-the-fly transformation. PDTs they're going to give you query speed over data freshness, so complex analytical aggregations. The customer health is one really good example, right? We're taking data, we're taking usage data, we're taking Zendesk data, we're taking CRM data, we're taking finance data, we're rolling that up into a big customer health score. You know, we don't want to be doing that on the fly. That's a lot of complex analytics. PDTs are a great choice for that. Better than ETL because we can quickly modify those health scores as we introduce new features and want to integrate them into the health score, so we don't need to go rebuild data pipelines. We can just go ahead and change that SQL. Data groups is a feature that we talked about before that they're useful for the cache. They're also useful here. So I'm not sure if you guys are aware of this. This is a pretty new feature. But you can use data groups to align your PDT builds to your ETL latency. So as soon as your ETL is done, so maybe select max ID or max timestamp from table, that's how I know that my ETL job is finished whenever that value updates, and immediately trigger a new PDT build based off of that. So we can align these to a greater degree of precision than we used to. And another thing you can do with PDTs these days that you couldn't do before is reference lookML calculations inside of the PDT. That used to be the single biggest potential source of confusion within Looker, or the potential for competing definitions, is if you have one definition in your lookML and another in the raw SQL that you're using to build your PDTs. PDTs can now reference lookML syntax inside of them, and so that's, you know, reduces a potential source of confusion. But so we have these PDTs, right? Really good for complex things where latency is okay, going back to that list of questions, right? If latency is acceptable, PDTs will help us optimize our speed, versus on-the-fly transformations. Of course, you can still use derived tables to achieve all the same analytical patterns. You're just going to be trading off that you're going to have a little bit slower query time in exchange for a little bit fresher data. There's a few additional features you can use there, such as parameters and templated filters. These are going to allow you to do things like on-the-fly cohorting, on-the-fly peer comparisons, taking one group and looking against other similar subgroups. Maybe you have a view file that should be able to reference one of 50 different tables, and you want that to be a user parameter. These are all things that are going to be more possible with on-the-fly transformation for those quick use cases that don't require as complex transformations. Once you have your model, then we think about query speed. And I'm not going to go through all of these in detail because Joseph and Joseph already touched on a few, right? But optimizing queries, again, there's a trade-off. Am I optimizing the kind of queries that people need to be running on the fly versus am I optimizing the kind of queries I can predict? So on the left, we talk about a few of the levers for people to be able to optimize on-the-fly queries. Default filters, I think, are really good, having a default time horizon. So for example, we have an explorer that we use to have all that customer usage data, and we have some dashboards on it, and literally the dashboard title says like date filter parentheses, please keep it short. Simple stuff like that to limit the query size. Really helpful, especially if you're connected to a read replica of a transactional database, right? That's not going to be optimized for analytics. Please don't ask that database to do more than you really need it to. Templated filters, adding extra predicates to join. This is a super nerdy feature. But if you've ever noticed that sometimes you have a join and the database takes a while to do it, and then you add more clauses to your join, and it doesn't change the logic. The numbers are still the same, but it runs a lot faster. Sometimes, depending on what database you have, your query optimizer can actually be helped if you tell it additional join predicates that are logically redundant, but nonetheless help. Or if you're filtering on a date, adding that date to your join predicate. So templated filters are something that you can insert into your join clauses in lookML to help your query optimizers. Aggregate awareness is, we already talked about that, right? Daily, monthly, weekly, transactional rollups to sort of point at the right table. So those are going to all be levers that you have available for optimizing on-the-fly queries, as opposed to the levers that you're going to have to optimize queries that you can predict, such as using the same data group. So you've got your data group, which checks your ETL, which builds your PDTs, which then builds your cache. One feature that we've released in the Looker scheduler is the ability to parameterize those schedules. So maybe I have a dashboard which shows sales for a store, and I have 100 store managers. I can set a schedule that loops through those 100 store managers and pre-warms the cache with 100 versions of those dashboard, one for each. And so I don't have to have load on the database when they all log in, Monday at 9 a.m. And then your delivery method, right? Obviously, we've talked a little bit about having people log into Looker versus different applications. I think embedding this is really important. And we talk about embedding in terms of customers, embedding it to their customers. We don't talk about it as much as in terms of embedding in internal applications. But again, going back to this idea of just-in-time analytics. If I'm an account manager and I'm about to go have a meeting, with Deliveroo, and I pull them up in Salesforce to see, their information, I can have their customer health information embedded right there in Salesforce. So really easy to do that, taking iframes, embedding them into the applications that people are used to. And then alerts are also really powerful, right? So when you have anomaly detection or notifications, have this trigger an alert, and it doesn't have to be email. Email is going to be one of those default options we give you out of the box, but you can have this alerted and sent to Slack. Send it into Zapier and do whatever else you want. Send it to SMS. So these are all going to be possible with the Looker platform. And then the Action Hub, which Colin briefly showed, actually gives you the ability to build custom integration. So if there's a delivery destination that we don't have, you can actually build your own. So there's a lot of features, right? But the good news is that they blend together really well. And so sort of just to summarize all this, if we go back to that spectrum, we asked ourselves these questions. Well, what's the latency requirement? Single source or multi-source? Do I need historical data, or can I just look at the data from just now? And then when we use that to plot our use cases, sort of operational versus analytical, and then there's this whole set of features that goes with it. So operational use cases, cheap databases, transactional, real-time, on-the-fly data modeling, which gives us slightly slower queries, but avoids any latency. It allows us to parameterize. We keep the queries small, we keep the queries fast, and we deliver it to you when you need it in the applications. And you can sort of see all those fitting together, and that's the stack that we're using for things like those alert notifications that we talked about. Versus analytical things like I need to be able to get a holistic view of customer success. Really good to use MPP databases. It's okay if it's a batch load, because my analysis for a big question isn't going to change in the next 30 minutes, really. We're doing some transform on load to keep our data in an analytics-friendly format. We're using PDTs to bring multiple data sources together, create aggregate metrics. We've pre-warmed the cache. We've aligned that cache to our PDTs. Our PDTs are aligned to our ETL. And we're doing this either in an Explorer environment, which is optimized for doing those ad hoc questions, or bringing this into other applications where you might log in, such as a CRM. And so hopefully that gives you a view of all the different levers you have. I know it's a lot. But yeah, that's basically all the ways that you can get analytics when you need it.